Hello everyone, this is Dr. A classes for BTech students. This lesson titled Glacial Erosion is the seventh topic in engineering geology. This lesson discusses how moving ice wears away the land, transporting sediments and reshaping the landscape over time. It is designed to provide BTech civil engineering students with essential geological knowledge. Learning objectives of the courses, explaining the process of glacial erosion, discussing some of the landforms that are created by glacial erosion, understanding the impact of glacial erosion on the landscape, identifying the factors influencing glacial erosion, evaluating the effectiveness of different erosion control measures that can reduce the impact of glacial erosion. What are glaciers? A glacier is a large, slow-moving mass of ice that forms from the accumulation and compaction of snow over time. It moves under its own weight due to gravity. Glaciers are found in cold regions and high altitudes where snowfall exceeds melting. Formation of glaciers. In regions with persistent snowfall, snow accumulates in layers over time. The weight of the upper layer compresses the lower layers, turning snow into compact granular ice called firn. Further compression and recrystallization transforms firn into solid ice. Due to gravity and internal deformation, this mass of ice it starts moving, forming a glacier. Movement of glaciers. Glaciers move very slowly at a rate of a few centimeters to meters per day. The movement occurs due to internal deformations. Ice crystals shift and realign under pressure. Basal sliding. The glacier slides over bedrock due to melting at its base and acting as a lubricant. Types of glaciers. Glaciers are classified into two major types based on their location and area of origin. Continental glaciers that include ice sheets and ice caps, and the valley glacier. Continental glaciers. These are massive ice sheets that cover large land areas extending beyond valleys and mountains, moved outwards from the center due to ice pressure. The ice sheets extremely large and spread over continents. Ice caps is smaller than ice sheets but still cover a large area. Valley glaciers. Valley glaciers form in mountain regions as the snow accumulates in high altitude areas and compresses into ice. They move downwards through pre-existing valley due to gravity. Glacial erosion processes. Glacial erosion occurs as moving ice modifies the landscape through various mechanical processes. The two main processes responsible for glacial erosion are plucking and abrasion, with additional effects from meltwater erosion and ice thrusting. Plucking or quarrying. Plucking happens when meltwater at the base of a glacier seeps into cracks in the bedrock. As the water freezes, it expands, loosening and breaking off piece of rock. The glacier then lifts and transports these rock fragments as it moves, further deepening valleys and shaping the land. Abrasion. As the glacier moves, rock fragments embedded in the ice act like sandpaper, grinding against the bedrock. This process smooths and polishes rock surfaces, creating features such as striations, linear grooves, and rock floor, fine sediments. The intensity of abrasion depends on the hardness, size, and concentration of the embedded debris. Meltwater erosion. Meltwater from glaciers can flow through cracks and tunnels beneath the ice. These subglacial streams carry sediments that erode the underlying rock, deepening channels and contributing to landscape modification. Meltwater erosion can form features like glacial potholes and subglacial tunnels. Ice thrusting. In some cases, glacial movement can push loose sediments forward, bulldozing material and reshaping the terrain. This can result in landforms such as push moraines and glacial thrust ridges. Factors influencing glacial erosion. Factors influencing erosion include ice thickness and glacier velocity, amount and size of rock debris, bedrock composition and structure, temperature fluctuation, and climatic conditions. These factors collectively determine the extent of glacial erosion and shaping landscapes. Ice thickness and glacier velocity. Ice thickness. Thicker ice exert greater pressure on the underlying bedrock, enhancing erosion through increased plucking and abrasion. A heavier glacier can also incorporate more rock debris, further intensifying the erosive process. Glacier velocity. Faster moving glaciers have a greater ability to erode landscapes. The movement depends on factors like slope, basal water, lubrication, and the amount of ice present. Higher velocity results in more pronounced glacial landforms like U-shaped valley and cirques. Amount and size of rock debris. The presence of rock fragments within the glacier acts as a natural abrasive. Large rock debris helps in plucking and gouging deep marks, striations on the bedrock, while finer debris enhances smoothing and polishing of surfaces. A glacier with abundant debris is more effective in erosion than a clean glacier with minimal sediments. However, if too much debris accumulates, it can act as a protective layer, reducing erosion at the glacier base. Bedrock composition and structure. Rock type. Soft, less resistant rock such as limestone or shale erode more easily than harder rocks like granite or basalt. Rock structure. Fractures, faults, and joints in the bedrock provide weak points where glacier can exert force, making plucking more effective. Bedrock with many cracks allows easier removal of rock fragments, accelerating erosion. Temperature fluctuations and climate conditions. Temperature variations, freeze-thaw cycles contribute to mechanical weathering, weakening the bedrock and making it more susceptible to glacial erosion. Water seeps into cracks, freezes, expands, and fractures the rock. Climate. Warm-based glaciers in the temperate climates experience greater erosion due to increased basal melting, facilitating movement and plucking. In contrast, cold-based glaciers in polar regions remain frozen to the ground, limiting their erosive capabilities. Landforms created by glacial erosion. Glacial erosion creates various landforms through processes like plucking, abrasion, and ice movement. Some key landforms include cirques, arrêt and horns, U-shaped valley, hanging valley, roche montagne. Cirques. Cirques are ball-shaped depressions at glacial head as shown in the picture. Arcs and horns. Following picture depicts arcs and horns. These are sharp ridges and pointed peaks formed by multiple glaciers. U-shaped valleys. U-shaped valleys are carved by glaciers. These are in contrast with V-shaped river valley as shown in the following picture. Hanging valleys. Hanging valleys are elevated valleys left by tributary glaciers. Rochemontane. Rochemontane are asymmetrical rock formations smoothed by glacial movement as depicted in the following picture. Glacial deposits. When glacier melts or retreats, it deposits its load in different parts. The debris thus deposited are called moraines. Depending upon their location in the valley, moraines are classified into terminal moraine, medial moraine, lateral moraine, recessional moraine, and ground moraine. Glacial deposits and moraines. Glacial moraines provide crucial insight into past glacial activity, helping scientists reconstruct climate changes and glacier movements over time. Lateral moraine. Lateral moraines form along the side of a glacier and consist of debris eroded from valley walls. They appear as ridges running parallel to the glacial movement. Medial moraine. Medial moraines develop when two glaciers merge, combining their lateral moraines and forming a central ridge of debris along the glacier surface. Terminal moraine. Terminal moraines are deposited at the farthest point a glacier reaches, making it maximum extent. These moraines create ridges of unsorted sediments. Recessional moraine. Recessional moraines form behind terminal moraines when a glacier retreats in stages, indicating temporary pause in its movement. Ground moraine. Ground moraines are a widespread thin layer of till left behind as a glacier melts, creating rolling and irregular landscapes. Glacial erosion and climate change. Climate change is altering glacial erosion, leading to significant environmental and societal consequences. Understanding these shifts is crucial for future planning and hazard mitigation. Impact of climate change. Increased melting. Increased melting reduces glacial mass, altering sediment transport. Proglacial lakes form due to retreat, increasing flood risk. Glacial surges causes temporary intense erosion and instability. Exposed bedrock leads to weathering, sediment release, and ecosystem changes. Long-term implications. Alters sediment supply, impacting rivers and marine ecosystem. Contributes to sea level rise, affecting coastal regions. Influences freshwater availability and human settlement. At the end of the presentation, these are self-assessment questions. Go through each questions carefully. Answer these questions based on understanding of the topic. Review any concept you are unsure about. The questions are: discuss the different types of glacial erosion and explain how they contribute to shaping glacial landscapes. Explain how factors like ice velocity, ice thickness, temperature, and the type of bedrock influence the rate of glacial erosion. Explain how is the rate of subglacial meltwater erosion influenced by factors such as water flow and temperature. Describe how human activities such as climate change, deforestation, and infrastructure development can affect glacial erosion rates and pattern. Discuss the stages of glacial landscape evolution from their formation in upland area to the retreat and deposition process in lowland regions. Thank you for joining this lesson on engineering geology today. Hope you found this presentation informative. Don't forget to like and subscribe the channel Dr. A Classes for more engaging lessons on core subjects of civil engineering. Thanks.